So as Dr. Ledger said, we are the seed pod manufacturing group. I'm Grant Condell. I'm in the shop. Then the group. So our project motivation for actually making these seed pods and doing this reforestation drone is that since 1990, over 420 million hectares of forest have been lost to deforestation. To put that in perspective, that's an area roughly the size of Australia. And nowadays, only 18% of the world's forests are protected from deforestation. And of that 18%, a lot of that is still subject to illegal logging. The main reason we wanted to utilize drones as opposed to traditional styles of reforestation is that normal reforestation is expensive, it requires a lot of planning and a lot of manpower, and it's just overall really time consuming. So for our project scope, we need to design and create a system with all of the manuals and plans and make this system that produces 8,000 seed pods per day. That's on a 24-hour basis. That gives us about 10 seconds per seed pod. All this will end up having to be open source so anyone can make it and build it. And we also are looking at making sure we can specifically accommodate one seed type, which we'll discuss in a minute. And then we have to integrate it with the drone team that talked earlier. And then we're expecting to run this like in a garage or indoors, but we plan to make it to withstand reasonable climate conditions, which is light winds, no rain, sunny day. So who is doing similar work? From left to right here, we have Flash Forest, and they are located in Canada, I believe, and they are doing a round type seed pod with the drone. All three of these are working to combat forest fires. The middle one, however, mass reforestation, they are based out of Washington, and they work to reduce carbon emissions for companies. So companies can purchase their seed pods and reduce their emissions. The one on the way right, the air seed, that company is based out of Australia.
So our concept of operations, the odd mixture itself is going to include part dry soil and part dry clay, and then will be added to a mixer. Once it is all mixed in the mixer, the material will then be loaded into a hopper with an auger. The auger will then load the material into a mold with a chosen seed type from a seed hopper, and then the product will be pressed until it is fully rigid, extracted from the mold, and then stored, ready to be used.
So these are our seed pods. Our initial kind of iteration one was this round type seed pod. We were having a lot of trouble getting those out of our initial mold. A lot of problems with them ripping apart as we were trying to take them out of the mold. It was overall, we weren't able to make them with any sort of consistency. So we moved to a sort of cylindrical puck seed type. They still utilize the same amount of materials. And that one we were just able to, crank them out, get them out of the mold with consistency and just make really similarly sized pods that will be able to work with the drone team pretty easily.
So then for the seed pod materials, what does it actually consist of? So we started out with Miracle-Gro, more of a potting soil, and we found out that had too much air in it, and it just wouldn't stay together. So then we switched to the topsoil, and with both of these, we tried clay powder and psyllium powder. The psyllium powder turns into like a gums like consistency once you get it wet. So we ruled that one out, which was okay because the clay powder ended up working out perfect for us. We started with about 50%, and it was so hard you could throw it across the room and it wouldn't break. So now we're looking at more of 5 to 10% of clay powder. And we also will have to possibly add fertilizers and herbicides if they're not already put on. And these we're looking at purchasing instead of using sources due to consistency and avoiding having to break down material on site.
For the type of seed we're using, we chose Rosa Pine, mainly because it's suitable for the needs in black hills, South Dakota, and because we also made a wide variety of seeds. And some examples of seed with similar or smaller size to the Rosa Pine seeds are Eastern White Pine, Fish Pine seeds, Western Red Cedar, Douglas Fir, Western White Cedar, and Red Maple.
So seed pod testing, this is kind of our first semester testing. As you can see in this picture, this is what we were experiencing essentially every time that we tried to make a round seed pod. You can see it gets stuck in the two halves of the hemispherical mold. The mold and press materials, we were utilizing a 3D printed filament called PETG, and the white material is polyethylene. We tried to use polyethylene as it's used mainly in kitchen applications and like non-stick cutting boards and stuff like that. But we were still able to actually use this mold. We just flipped it around and used the flat ends as opposed to using the machined hemispherical ends. We determined that each puck takes about 50 PSI to form. So we use that to kind of spec out what kind of motors we're going to need. And yeah, as we discussed, the ball just really wasn't working out. We would have liked it to. We tried for quite a while, but we just couldn't get it to work with any sort of consistency, so we moved to the pucks.
So this is our testing apparatus design. So we started out with a quick model, and we used a hexagon shape, which ended up proving that the material got stuck in the edges. So on where there wasn't the actual seed pod hemispherical shape, the material would get in between there and it wouldn't be able to form. Then we moved to just a round cylinder, and just the mold, and got the wall. So basically there was no mold material between the outside of the hemisphere and the actual cylinder. And then we ended up using that last one on the right was the flat shape. So we just pressed two pieces together and that ended up working.
So to start will be the mixer, which works kind of like a cement mixer, where you pour the material in there, and then it'll spin 360 degrees. With the wedges on the inside, it'll dig into the material, mixing it up. It's got a ring of gear teeth around the edge that'll be what it's going to spin it. Then it'll be able to pour or to rotate on its side to pour into the auger. In order to accommodate for the amount of pods we need, it's going to have a minimum of 7 3/4 inches. The smaller wedges on the inside could be 3D printed, otherwise they have to buy mostly out of space.
For transferring the material from the mixer to the mold, we will be using another conveyor. So this tool will rotate and push the material to the mold, ensuring efficient and fast delivery. And with this system, we can easily handle some potential amounts of material at once, and we won't have to worry for the risk of getting stuck in the middle. And for the other manufacturing, we're planning to make it 15 inches long, and we're looking into running options to ensure durability and quality. And for our design considerations, we're exploring the use of anti-friction additives and steel bearings to minimize friction when making.
So for the press design, we're utilizing a reciprocating press, basically using a reciprocating rack pinion. So as you can see, it's a gear that only has a couple teeth, and then it has gear teeth on the top and bottom. So as it spins, it has to go up and down and back and forth. This results in about 4.5 inches of travel, which is right where we want it to be able to come out and go all the way down into the press where we need it to go. And yes, this will be attached with a DC motor on the back that just allows it to kind of spin at a constant rate. And the motor will have to be decent high torque and low RPMs to achieve the amount of pressing force that we need to make these pucks stable.
So for the mold design, we're planning on 3D printing. The primary reason being able to make it open source. And that also allows us to make a very flexible design. So any design changes will be fairly easy to implement. Another reason is in case we cannot get the material that quits sticking to the sides, we could insert some sort of metal insert or a different material into the print and not have to replace every individual belt every time. So with this design, you can see it's kind of that outside cylinder implemented into a conveyor style belt. So this will just allow us to integrate the molds into a continuous loop around a rail system. So for the rail system, we initially thought of using some sort of conveyor belt. This will be gear driven, and we could use either 3D printed gears, or we could purchase a chain that the conveyor belts will attach to. And then this will just wrap around and run around.
Here's kind of our general flow diagram. Up at the top, we have obviously our top level system being the whole seed pod maker itself. That kind of splits into 3 separate subsystems: material preparation, the seed itself, and then the actual seed pod formation. The material preparation, you have your mixer tumbler, and that consists of your motor and your actual mixer barrel. That moves into the material transport, which is the hopper and the auger. The seed is then loaded in with the material and pushed into the press. And the press consists of the ram and the mold. We found out that fresh out of the mold, they will work all right, but they're kind of like a malleable, almost like a modeling clay type consistency. But if we let them dry for about 24 hours, they turn into a nice hard puck that when it's exposed to water or the elements breaks down fairly quickly and deposits the seed and the mixture into the soil.
So this is our fall 2023 Gantt chart. So this just shows everything we've done up to this point to get to where we are. So primarily designing the models, which we will finish up next week. And then also our initial testing, which was determining that seed pod, the round one, didn't like form and crumble, or which wouldn't come out of the mold, and switching to the pod shapes. So then this is for the spring semester. Everything will be in the future in order to make sure our project is completed. So we'll finish up the designs this semester and then right away get started ordering materials. Then we'll get all of the components built and then test them and then put them all together and test them again. And it's expected to be about February. We can hopefully have this entire assembly mostly built and tested, which will give us plenty of time to fix any of the issues that arise.
It's kind of a rough budget. We have our shielding materials, 3D printer filament. Our auger is likely going to have to be a purchased part. We couldn't really figure out a way to efficiently 3D print that. Our concrete mixer is pretty easy to purchase from places like Lowe's or Runnings. Structure materials is going to probably consist of extruded aluminum rails. And then obviously our various stuff like our hardware, electronics, potting soil, topsoil, and then our clay powder and psyllium powder, which is already purchased, but we're not going to continue using as that was more of a one-time expense. All told, we're looking to spend around $2,100 on this project, and I think that some things up there are a little overshot. So if we can reduce that further, I think we'll be pretty well in the clear there. Any questions?
A couple of like mixer. Let me go back to that spot there. Was that you're looking at purchasing a cement mixer or?
More than likely,
Okay.
it honestly makes more sense to purchase one.
Okay, I was gonna say, I was wondering if you're how like how big your batch is with that one? Or if you're
Yeah.
like looking to do like a whole bag of topsoil at
Yeah, so we plan to do like a whole bag of topsoil, and then you measure out the
Yeah.
clay powder and dump that in. And then that would go into the auger, so that in there would be big enough to hold basically that one batch.
Okay. The current mixture we're looking at, and we're mixed by weight, not volume, is about a 20% clay to 80% topsoil mixture. That's about the lowest end of clay that we can use. And it still remains structurally stable fresh out of the mold, because we did a 10% ratio and it worked fine after it dried, but it was really kind of touchy and crumbly out of the mold. So that's kind of what we're looking at. Hopefully mixing up enough to do the entire day's batch, or at least a substantial amount in one go.
Do these seeds start germinating in the pod while they're getting stored, or what's like the timeline? How soon do you have to use these things?
So we're gonna get seeds that have already been, it's stratified or something like that, but they're basically already prepared. So that they're ready once they have the proper amount of warmth and moisture, that they'll just start germinating. But the hope is that they don't start germinating in the pods like immediately, but more so, once they've been dropped onto the ground and kind of started to disintegrate and get hit with a little bit of moisture and some sunlight, that they'll hopefully start to open up.
How much rainfall it would take for to fall apart? And
We did some testing in the lab, and it took about 2 minutes of running under the sink for the seed pod to fully kind of disintegrate into a really wet, just powder. So that was the other thing too with the balls versus the pucks. The pucks seem to disintegrate with water a lot faster, more efficiently. They took a lot less, whereas the balls themselves, I mean, to be soaked, they really didn't seem to want to break apart, but the pucks seem to break apart fairly readily. So it shouldn't take much, especially in a place like South Dakota. Rainfall is unfortunately not all that common.
You talked about one batch being a bag of potting soil. How many pots did that make?
I think that's one bag is a little much. What each pod right now is about 10 to 14 grams of mixture. So that it would be a decent amount to make 8,000 in one fill. So it'd probably be about 16 pounds of mixture in the deal itself.
How much in one bag? 40-pound bag?
It felt pretty heavy. I'd say about 40 pounds. 40 pounds.
So one bag makes 2 days.
Probably, yeah.
So when you guys did your testing with the balls, you had your cylinder and it looked like you're pushing forces from both ends. Were you then separating it by pulling both ends? Or did you guys try pushing it through completely? So maybe gravity could help drop it out of the mold rather than you pulling from both ends?
We basically what we would do is we use halfway the height of the cylinder as kind of our measuring for how much mixture we're adding before we start measuring by weight. So we would have the bottom set in there, and then we would fill the top half and then press it down at the top, and then we would try to remove one side at a time. But no matter what kind of configuration we tried, we were still having a lot of issues with it sticking to either side and wanting to tear apart, just because there's so much less surface area at the cross section of a sphere than there is on a half of it. So I just wanted to stick to that mold way more than want to stick to itself.